Hello everyone, welcome to my YouTube channel. My name is Durvil and today I'm going to show you how to solve question about electrical network. For you to be able to solve question about electrical network, you must understand how this table works. You can see in this table we have three components. We have the capacitor, the resistor and the inductor. On the other side we have three columns also. The first one is a voltage to current, right? This is how we write the first line here. Where they say VCT is equal to 1 over C integral of IC t dt. So this is how we can write the voltage of the capacitor. The voltage of the capacitor. Down here we have the VR. This is how we can write the voltage of the resistor. And then here we have VL. This is how we can write the voltage of the inductor in another way. Here also we have the current, which is C over D over dt VC. This is how we can write the current of the capacitor. And then we have IR, the current of the resistor flow through the resistor. We have IL, the current through the inductor. And on the other side we have the impedance. I won't waste a lot of time explaining using this table. I will take an example where I'm going to explain this table and the same thing also, what's going on also, how to solve question also about electrical network. I picked this example, guys. I picked this example to solve. I'm going to solve this question and show you how to apply those rules there on the table. Guys, the first thing when you are in front of your question about electrical network, you must first check in your circuit how many components you have. How many components that you have and which type of component that you have in your circuit. Like now I have three components. I have two resistors, and then I have one capacitor. And on the other side of the question, you must also check what's the question. But most of the time, they're going to ask you to find the transfer function of V out over V in. So which means the voltage at the output over the voltage at the input. So after done checking how many type of capacitors do you have, how many type of resistors you have or inductors, and which voltage, what is the question. And now you must check which type of circuit that you have. Is it a series circuit or a parallel circuit or series and parallel circuit in one circuit? So guys, you can see here, this will be my total current. You can see this will be my total current, IT. That total current will flow from the source and then it's gonna arrive here and split in two parts. One part of the current will come here, another part of the current will flow this side. So which means here I have a current that flow here that I can call I1, and I have another current that flow this side that I can call I2. So you can see that we have a series and parallel circuit. Series because the current here is gonna flow first here on resistor R1, the total current, and then that total current will split into part on I1 and I2. So automatically this capacitor and this resistor R2, they are in parallel. Now we're done interpreting the current. Let's check about the voltage now. I have an input voltage here which is V out and another input voltage I have an output voltage here which is V out, and I have an input voltage here which is V in. But check, this V out is connected here. Let's say we have a voltmeter is connected here, which means this V out is measuring the voltage of the resistor. Is measuring the voltage of the resistor R2. But the fact like R2 and R and C and the capacitor that are in parallel, automatically the voltage also in the middle here is a V out. So which means C and R, they have the same voltage that you call V out. So in this way it's become very easy. It's become very easy because you have already two component that has the same voltage. Only this other component, we have only one component on the other side. So to solve this question, we can use the current rule by saying I total, the current from the source, is equal to what? It's equal to the current I1 plus the current I2 So which means I total is equal to the current across the capacitor plus the current across the resistor. But the problem, check here, my I total flow through the whole of it, the whole current flow through this resistor that we call R1. Guys, remember in the electrical network they won't give you values. Here they want only to see formulas. They only want to see component. So that's what make that's the part that make this type of circuit to be difficult, because you used to solve questions like this but with values. But this time they won't give you values. They want only the formula. So let's see this time. So we have I total. So let's check. This current is the one that flow through the resistor R1. So we can say I total is equal to what? Ohm's law, because we know that Ohm's law, let's say resistor, Ohm's law is equal to the voltage over the current. Ohm's law. Sharp. So we can say what? We can say I total is equal to voltage across the resistor R1 over resistor R1 using Ohm's law. And then now we're done. But let's check about the current across capacitor C1. Sharp. So for this time now, because the capacitor is another component, because you must check the capacitor. So by this time you must interpret using that table, because we know already for the resistor we applied current divider. But for the capacitor you must go and refer to that table that I showed at the beginning. Let's go back to that table. You can see here they say the current through the capacitor is equal to the capacitor times D over ddt times Vc. So let's go back now. Let's go back. We arrive now here. Let's go back here. So which means the current here across the capacitor is going to be C, which is equal to D over ddt times Vc. But the problem, we say what? This Vc, it's the same thing and V out. So we can write that Vc and say Vc is equal to V out. You see that, guys? And then plus I2. I2 is the current that flowed through the resistor R2. So we can say what? R2 is equal to what? R2 is equal to the voltage of R2 divided by resistor 2. But the problem, we know that, guys, V out, the voltage across resistor R2 is the same thing and voltage and V out. So in another way you can say that it's equal to V out divided by R2. So guys, you see how we interpret what's the role of that table. So let's check now. Let's move on now. Now we say, look guys, now the problem is the voltage across, because we need for you to be able to solve this question. In each and every term in your equation, you must have a voltage V out or V in each and every term of inside your equation. Like in each and every term here, I need to have V out or I need to have V in. Because like this, when I have VR1, I can't solve this question. I can't have V out over V in. So which means on this side also I need to have a V out or V in this side. So how can you do that? Let's see, guys. Let's go back to our circuit and see, guys. Guys, look, we say that this whole part, the voltage across this whole voltage across this part, it's equal to V out, because C and R2 are in parallel. So automatically, what can we do? If we solve this parallel, we're going to have something like this. Let's solve that parallel. We're going to have a resistor R1 like this, and then we're going to have, let's say for example, my parallel of capacitor and resistor this side. So automatically, if I want to know the voltage across resistor R1, this is my V total. Let's say this is my voltage total, and I know the voltage across this part. This voltage is equal to what? V out. So automatically I can say V in, the voltage total, which is V in, minus the voltage across this side, which is the capacitor and the resistor, it's equal to my voltage, the voltage across R1, VR1. So guys, here, let's go back. I can say VR1. I can say VR1 is equal to what? Is equal to the voltage in minus the voltage out. So the voltage of these two components, the resistor and the capacitor. So which means the voltage total minus the voltage of the resistor and the capacitor. Here I have my VR1. So I can deduct this thing in my table, in my equation, this equation. So I can change the color of the pen. I can see now my V by VR1 is gonna be V1 minus V0 over what? V over R1, which is equal to C over D, C times D over DDT times V0 plus V0 over R2. You see how easy is it? So by this time now I have a problem. How are we going to solve this DDT over D over DDT? So DDT, to solve that one, DDT over D over DDT, we're going to have V1 over V0 times minus V0 over R1, which is going to be equal to what? To solve this thing, to cancel this thing, we need to introduce S. When we introduce S, we solve this part. To solve the D over DDT, we introduce S. V DDT change to S. So we're going to have now V times V0 plus V0 over R2. Guys, here we have R1. So guys, you can see now in each and every term in my equation, like here I have V out, I have V in and V out. Here I have C, I have CS and V0. Here I have V0 and V and R2. So you can see I have in each and every term I have V out or I have V in. So automatically now it's become easy for me to solve the equation. You can just apply all mathematical techniques that or rules that you know. So my V out over V in is going to be R2 over R1 plus R2 plus R1 R2 CS. So this how I solve my equation. Guys, you can see how easy is it to solve question about electrical network. I'm going to pick another example and I'm going to show how to solve that equation. So guys, you can see I will come back in another video to show you how to solve this. Here by this time we already solved everything. You need just to apply your mathematical rules. You send, for example, I can send my R2 here. I make R2 the common denominator, and I send that R2 this side and send R1 that side, and I solve, and then after that I will come back to this equation. Thank you for watching the video, guys. Don't forget to subscribe, and I will see you in another video. I think if you subscribe, I will make more and more video, guys, for you to be able to understand and to be able to solve any question about electrical network. And thank you. Bye.